morning students. Today in this video we are going to discuss our chapter 8, that is first chapter of physics, that is motion. Okay, and these are the topics that we are going to cover in this first video. So the first topic is states. Okay, now you see any object, okay, it has two states in physics. Like in chemistry it had three states, like solid, liquid and gas. But in chemistry it has two states, that is rest and motion. An object can be at rest or at motion. Okay, now physical quantities and system of unit. And the third topic, distance and displacement. Fourth, speed and velocity. Fifth, average speed and average velocity. Okay, so we are going to discuss these topics in this video. So now we will start our first topic, that is rest. You see in physics, okay, the object are whether at rest or at motion. Okay, so at first we will discuss about rest. We will see what happens when an object is at rest or stationary. Both are same thing. Okay, rest or stationary, both are same term. Now fixed at one position. The objects are fixed at one position when they are at rest. Okay, for example, trees, houses, okay, they do not move from one place to another. Okay, they are always fixed at one position, and like some examples are tree, houses. Okay, is it clear? So what happened? In motion, an object moves continuously with respect to a stationary object taken as reference point. Now when you are coming from home to school, okay, your home is the reference point. From home you are coming to school. Okay, so is it clear about rest and motion? In rest the object are fixed, and in motion what happened? The object is moving continuously. Okay, for example, in our body also you see blood, they are moving continuously. Again, birds are flying. These things are what? Motion. And we know that, see, motion are of different types, right? Straight line. Motion in a straight line is called what? Rectilinear motion. Again, rotatory motion. Again, oscillatory motion. Different types of motions are there. Means the way they move. Okay, the path they choose to move. Suppose this motion, I am coming from home to school in a straight line. Then this will be a rectilinear motion, right? Suppose I have to take one round to come to school. Then it is a circular motion. And if I am rotating again and again, then it is a rotatory motion, is not it? If I am going to and fro in a swing, it is a oscillatory motion. So these are what types of motion. Okay, I hope it is clear about rest and motion. Now let us move to another topic. Okay, students, now we will discuss our second topic, that is physical quantities. What is physical quantity? You see, all those quantities which can be measured are called what? Physical quantity. So the quantity, anything which can be measured are called what? Physical quantities. Okay, some example, length can be measured, right? Mass can be measured, time can be measured, again temperature can be measured, force, pressure, work, these things can be measured. So it comes under the physical quantities. Okay students, now you see what happened. Again, this physical quantity is divided into two types. Okay, scalar quantity and vector quantity. You see, these scalar quantities are not dependent on direction. They don't depend on direction. Okay, I will give you some example. Can be described only by magnitude, that is distance or quantity. Magnitude, what is magnitude? Any distance or quantity is termed as what? Magnitude. Okay, example, length, mass, time, temperature, density. You see length. Suppose when I am measuring length, okay, suppose a house is there and this is our school. Okay, then what happened? If I want to measure the distance, okay, the distance is suppose 5 kilometer. Okay, see, direction do not matter. If I come from this direction, the length will be same, and if I go from this direction, the length will be same, that is 5 kilometer, right? So it do not depend on direction. Now mass, okay, so mass is also a what? Scalar quantity. So these are some example of scalar quantity. In scalar quantity what happened? Direction doesn't matters. What matters is only magnitude. Okay, now let us come to vector quantity. What happens in vector quantity, you see? It depends on both direction as well as magnitude. Example, force. Okay, so force is an example of what? Vector quantity. Now let us take an example why force is vector quantity, why here direction matters. Okay, see, take one bottle, okay, and try to open the cap by rotating in clockwise direction. If you will apply 10 Newton also, what will happen? You will not be able to open the cap. On the other hand, if you will apply 2 Newton of force in anti-clockwise direction, which is the right way, what happens there? The cap will open. So in this example, what happened? Direction matters or not? If you apply force in wrong direction, the bottle cap will not open. But if you will apply force in right direction, what happened? The bottle cap opens up. So this is why force is referred as vector quantity. Okay. Now whenever we write vector quantity, always suppose force. Okay, when we write force, suppose force equal ma. Then we will write this arrow. Why we write this arrow? Because this arrow indicates the direction. Is it clear? Now, while writing, suppose length, we write only length. Suppose time, we write only t. We never put an arrow there, right? Because they are independent of direction. On the other hand, whenever we write any vector quantity, we put this arrow over the sign. Okay? So, is it clear about physical quantity? See, what is physical quantity? Anything, okay, those things which can be measured are called what? Physical quantities. Again, physical quantity is divided into scalar quantity and vector quantity. Scalar quantity, what happened? It depends, okay? It depends on magnitude and it do not depend on any direction. On the other hand, vector quantity, what happened? It depends on magnitude as well as direction. They always follow that direction. For example, force. And how we denote force? We write force by writing an arrow above because it is dependent on direction. Okay, is it clear about physical quantity? We will discuss about system of units. So far we discussed about physical quantities, right? So what were physical quantities? Anything which can be measured are physical quantities. Now, the things or tools which are used for measuring physical quantities effectively are called what? System of unit. Okay, or measurement of physical quantities are expressed in terms of unit which have standardized values. Suppose I have brought 2 kgs of potato. So here, what is the standardized value? You know, kg. Kg is the standardized value here. If I write only 2, it is useless, is not it? Nobody will understand what I am talking about, right? So the system of unit gives any physical quantities a standardized value. Okay, usually we use SI system, International System of Unit. Okay, why we use SI system? Because it is accepted worldwide. Okay, see, suppose I am buying potato, 1 kg of potato. Okay, here in India, then if I want to buy 1 kg of potato in America, the amount will be same. Okay, because it is accepted internationally. That is why all of us we prefer SI system. And some examples are, you see, like length, kilogram, meter, millimeter, centimeter. So these are what? SI units. Okay, did you understood about system of unit? We use system of unit to measure any physical quantities and the system of unit gives it an standardized value. Standardized value means, suppose I have bought 2 kg of onion. Then this kg is the standardized unit. Okay, if I say kg, it denotes mass. If I say liter, it denotes liquid, right? So these are what? Standardized value. Is it clear? Okay, now let us move to another topic now. Okay students, now we will discuss about distance and displacement. Okay, what is the difference between distance and displacement? So we will discuss about it. Now at first, let us learn about distance. What is distance? You see, it is actual length of the path, okay, by moving body irrespective of the direction in which the body travels. Now you see, it is the distance, it is the actual length of the path, okay, actual length. An object may move from any point to other point. Okay, it is the actual path, the total path that we calculate. is what? Distance. Okay. Now you see here I have given one example. What happened? An object is moving from point A to point B. So now the length of point A to point B is 3 km. Length from point B to C is 4 km. Length from C to A is again 5 km. To find the total distance, what I will do? I will add up these three lengths together. AB equal to 3 km, BC equal to 4 km, CA equal to 5 km. So the total distance is 12 km. Okay. Now you see it is a scalar quantity. So what is the difference between a scalar and vector quantity? In scalar quantity, what happened? The scalar quantity are independent of direction. Okay, direction doesn't matter. So here also direction doesn't matter from which direction it is moving. Okay, we can calculate the total distance by adding up all the small lengths. Okay, now let us discuss about displacement. Students, now we will discuss about displacement. Let us know what is displacement. Okay, you see, when the body moves from one position to another, okay, when the body moves from one position to another, that is from A to C, the shortest distance between the initial position and the final position. Now initial position means from where the journey is starting. A is the initial position and C is the final position where the body stops. Okay, along with the direction, okay, here direction matters. In displacement, direction matters. In distance, we have seen the direction doesn't matter. Okay, here what happened? The body is moving in this direction. Okay, is known as what? Displacement. Now let me tell you in simple words that displacement is the shortest distance between 2 points. Okay, now here what happened? You see this one from A to B, B to C, it is a longest distance, right? Now the shortest distance will be from A to C. Then A to C is what? Displacement. Okay, now you see what happened here. The distance, okay, how we will calculate distance? We will add A plus AB. Okay, AB, what is the distance of AB? 4, right? And BC, what is the distance of BC? 3 equal 4 plus 3, we will get 7. Right? But displacement, what is displacement? It is the shortest distance. So here the shortest distance is from A to C. How we will calculate? You see, you know Pythagoras theorem? Okay, now you see, according to Pythagoras theorem, AC square equal to AB square plus BC square, right? So AC square equal to, what is AB? Distance between A and B is 4. 4 square plus BC equal to 3 square. Now, if you will remove this square, 4 square is equal to 16 plus 9, that is 25. So, if we put a root over here, what happened? We get 5. So, here the displacement is 5. So, are both same distance and displacement? No, they are not same, right? And what happened? You see, this displacement, it depends on direction. That is why it is what? Vector quantity. Distance is a scalar quantity and displacement is a vector quantity. Is it clear about both? And what is distance? It is the longest length, right? And displacement is the shortest length. Okay. So, I hope it is clear about distance and displacement. Okay, students, now let us discuss our next topic, that is speed and velocity. Okay, so at first let us discuss about speed. You see, speed gives us an idea of how slow or fast a body is moving. When we see an object moving very fast, we say the speed is very fast, right? When an object is moving very slow, we say the speed is very slow. So, it gives us an idea whether the body is moving fast or slow. Okay. Now you see, speed of a body is the distance traveled by it per unit area. So how we can calculate speed of a body? Suppose you want to calculate your speed. How you will calculate? You see, what happened? Suppose you are running a race. Okay. So if you run 50 meter and by taking a stopwatch, okay, you found that you ran 50 meter within 2 minutes. So, what will be the speed of your body? Speed equal to distance by time. The distance you travel. So, how much you travel? 50 meters. In what time? 2 minutes. So, the speed of your body will be 25 meter per second. Okay. Now, so how we can calculate the speed of any body? By applying this formula. speed equal to how much distance you travel within how much time. Okay, and this meter per second, from where it came, you see, distance is what? It comes under length, right? So what happened? The SI unit of length is meter. Okay, so we write meter here, and the SI unit of time is second here. So if we divide each other, what happened? We get meter per second. Suppose you ran 100 meter within 2 minutes. Okay, within 2 minutes, then it will be 50 meter per second. Okay, and it is independent of direction. That is why speed is what? Scalar quantity. Here direction doesn't matter. Okay, so now let us discuss about velocity. You see, just now we have seen that speed is a scalar quantity, right? It do not tells us about direction because it is independent of direction. But velocity, you see, speed does not give the direction of motion. Where the object is moving, speed do not give us that idea. Okay, but to know the exact position of moving object, direction should also be known. To know where the object is moving, suppose the object is moving toward east, we should know the direction also. Okay, we should know the direction to know the exact position of the object. For that, velocity is required. Now you see, velocity of a body is the distance traveled by any object per unit time in a given direction. Everything is same, but in velocity what happened? Direction is needed. You see, velocity of a body is the distance traveled by any object per unit time. Okay, in a given direction. Now you can derive the formula by, suppose, velocity equal to distance traveled by an object at given direction. Okay, means what? See, just now we studied about displacement, right? What was displacement? It was the shortest distance along with the direction. So this definition is also same. So in place of this long definition, we can write displacement. Okay, shortest distance along with the direction by time is what? Velocity. So how we can write the formula of this velocity? Velocity equal to displacement by time. Everything is same among this speed and velocity. Only what changes in the velocity depends on direction, whereas speed doesn't depend on direction. Okay, so the formula of speed is speed equal to distance by time, and the formula of velocity is displacement by time. Okay, and what do you think? This velocity is a scalar quantity or vector quantity? Velocity is a vector quantity. Why? Because it is direction dependent. Okay. Our first video ends here. Later other topics we will discuss in the next video. Thank you and have a good day ahead.